What's going on, everyone, and welcome back. This is Giovanni, also known as CryptoJoe101 if you follow me on Twitter, and today we're going to be talking again about the Plutus Pioneer Program and Haskell. In this video today, I'm going to try to solve the Haskell exercises of week 3, where Professor Lars, hello Professor, has been explaining how the script context, time handling, and parameterized contracts work. And we have a couple of exercises to solve. The link to the actual lesson, the class should be somewhere around here, appearing in just 1 minute. And then feel free to watch it and then come back to the exercises to know how to solve them. Without further ado, let's show very briefly the project that is here, Plutus Pioneer Program. The week 4 is already out, lecture number 4 is already out, but I am not there yet. I will hopefully catch up very soon. Yeah, we will do today lesson number 3. Let's go into our console. The console is ready. I'm gonna give a nice clear and then jump on the ID. So this is the homework number 1. Let's close the other ones, close other tabs, and what we have to do here is if you have followed the class, basically, the example that we're trying to solve is a vesting contract where there is one person that makes a gift to give money to someone else, and another person that will be the beneficiary, that is the receiver, and there is a deadline. Basically, what happens is that the beneficiary 1 donates a lump sum to the beneficiary 2, but the beneficiary 2 has only a certain amount of time for getting, collecting or grabbing this money. And this is given by the deadline, so a number of slots. If the deadline passes, whoever made the gift can claim the money back. And that's it. So, very simple to say. Let's see if the code is going to be simple as well. So what we have to do is to implement this validator function, because Professor Lars has already filled all the other things, so we will be focused on this one. As we can see from the signature, the make validator function goes from vesting datum to the redeemer. In this case, here is the datum, here is the redeemer, but the redeemer, we don't care about this currently. And then here there is a script context. The script context is basically everything that belongs to the actual transaction. And then here is the boolean that is basically the result of the operation. So let's put names for the variables that we're going to be using. Context is this one, and this is the datum. We'll call it that. So we can't use the false anymore, but we will have to put a couple of conditions. So the condition that we're going to use are, I am still going to use the trace if false function that basically prints a log statement in case there is a failure if the resolution of the condition is false, and so we have an help into the logs to understand what went wrong. And in this case, the first condition that I'm going to check is that if the actual beneficiary if the current grabbing transaction is issued by the correct beneficiary, as the signature of the wallet signing this transaction is correctly the beneficiary number 1, and if the current slot is before the deadline, so that it's not expired yet. So what I'm gonna do is just like wrong beneficiary or expired deadline. So this means that chk ben1, or this means that either the beneficiary is wrong, or if the beneficiary is correct, we have to check that the deadline is not expired yet. Alternatively, actually I'm going to clone this one, I'm going to go to the bottom, wrong beneficiary, or wrong beneficiary 1 and beneficiary 2, so that we know which case is this one, or deadline not expired yet. So this is a case in which the beneficiary 2, that is the one who actually emitted the gift, is trying to collect his money back too early. So in order for this thing to work, we actually have to implement the functions as well. and we can use the where we basically say, we declare the condensed section, we say that this one is a function that returns bool, and the same thing with this one, and then we have to implement them. I already leave a little bit of space here because I know already that I will have to do some extra manipulation of this context. So let's start to work on this one. So the chk ben1 is a function that needs to check, first of all, if the beneficiary one, that is the one that receives a gift, is the one that is signing this transaction. So let's do this. First of all, we have to extract beneficiary one from the vesting datum, and the way we do this is by calling beneficiary one that is actually a function that is in scope when there is a data object defined like this one. Now my target object is this one, so I just have to do this one. Now, in order to see if the beneficiary one is the one signing this transaction, I will need to extract some information from the context, so the context of the transaction. So let's go to documentation and see into the context source file how to get this information. So first of all, the script context that we just saw into the source code is exactly this object here. So I need to get the transaction info from here, and from the transaction info I need to get the list of signatures. So there can be more than one. In this case, I guess it's going to be only one. So basically what we have to do is that from this object we have to get this property, and from this property we have to get this list. So let's do one step at a time. What I want first of all is an object of type transaction info, tx info. And in order to do so, what I need is basically this property. Hang on a second. Yes. Tx info is equal to this method of this object. So all of a sudden, from the context, I have the transaction info. I can now check if this beneficiary is actually, it's included in the list of the beneficiaries. So how I can do this is using lm. lm is basically a function. I'm using it as an infix. I can use it as a prefix. I'll do this in the next check. If this is part of what? I need this property, the transaction info signatories of the transaction info object. And this works like this. So extract this property from this object. But this is not over yet, because I also have to check if we are currently into the right and correct interval. And so it means that I have to check the current range slot. I'm going to do this by extracting this slot range from tx info. So I have something like a range of type slot range, and I can get that doing range equals tx info valid from tx info. So we're basically extracting again this attribute from tx info and storing into range. So now what I have to do is to check if an interval built with the two deadline of that. So I'm extracting the property deadline from the datum object that is here, and if this one contains the range. So if the range is part of the valid interval. So this should do. I think that maybe I have to put a couple of parentheses around this one. I will not do this one, just one yet, because I think this could be actually okay. But anyway, let's do the beneficiary do, the test for the beneficiary do. That is this following one. Here I have to check if the beneficiary do is actually in the list of signatures. But at the same time, this is not valid anymore. What I do need is that it's not to, but is from. So I need the deadline to be expired in order for this to be correct. So yeah, this should be the code. I have still a little doubt about the parentheses around here, but let's see if Cabal confirms that everything is fine. So I'm gonna call repl. Let's see if the compilation is fine. Otherwise, I'll fix the slot range. So a little bit nervous. Slot range. I can do a reload here. Let's see if it works. Yes, it looks like all the types are matching, so I can take this one now and I can go into the playground. I'll paste the code, no need to delete the module definition anymore, as this has been fixed for our joy. And now we can test the result. So already 1,000 Cardano put 1,000 Lovelace. This is actually showing already previous a previous test that I was doing. I'm gonna actually cancel everything and start from scratch. So the first thing that we want to do is to give the first wallet wants to donate, let's say 150 ADA. It's gonna wait for the time slot, deadline number 10, and now I need here the public key of the wallet number 2. In order to do so, we have to do a couple of little tricks. So we have to import the what was that again? Wallet.emulator, I think it is. Fantastic. So that we should be able to do wallet 1, and it should give us a wallet 2. This is another wallet. Now we need the public key hash for wallet, but in order to do so, we have to go through a couple of steps. The first thing is to take the public address and then transform this one into an hash. In order to do so, we need again import ledger, and we should have in scope something like type a wallet public key, and this gets a public and returns public key. So we could already do like wallet pub key of wallet 2, because that's the one we want to donate, and this one. And now we have to convert this thing into an hash. So there should be something else called pub key hash, I think. There we go, pub key hash, and this one should take a pub key that is exactly what we've done on the previous step and transforms it into an hash. So we should be able to concatenate those two functions called wallet pub key of wallet 2, put two parentheses, and this is the string that we were looking for. Now, and this is the first step. We need to give one slot for everything to settle, and then let's make like the happy case. We just do the grab and we wait again, and then basically we should see that the wallet 2 is able to collect these 150 Lovelace. Let's wait for a couple of seconds and we can see two transactions. The first one is the wallet one. It is actually moving 150 Lovelace as we expected. The cost is 10 and the remainder is 840. In these two, there is the script as inputs. The money goes into wallet 2, and that's correct. Fantastic. The next step is to try to make this thing to expire. So we wait 15 slots. We'll try to get the money, but this hopefully should fail. So we should only see one transaction, and that's correct. We only see the money going out, and this is still correct. Nothing is collected. And now there is a different thing that we're going to do. Instead of grabbing from the wallet 2, we will be grabbing from wallet 1, because the transaction, the slot time is expired, so we could try to grab the money back. We still have to give another wait of one slot just to ensure that everything is settling down. And we can see exactly 2 slots now. So wallet 1 emits the payment at 40, a remainder, and then 150 is what goes out. And now we see again that from the script it goes back to wallet 1 as the 140. They go back to the wallet 1. Of course, the fee are deducted again, and we should see again that basically there are 20 Lovelace missing, and these are the Lovelace used to pay the 2 transactions. We could also test with another wallet 3, and we can ensure that wallet 3, if attempts to get the money, will actually not get anything. So we'll go back into the slot number 5, for instance, and then wallet 3 try to grab. We should give them a little bit more money just to be sure that they'll be able to perform the operation if successful, but we should still see only one transaction. Exactly, wallet 3 can't steal those money, and this is exactly the same if we wait the 15 slots, because this is when basically the wallet one is allowed to get them, but again, only one transaction here. So this concludes the first exercise. It wasn't too complicated. The reality though is also that this code is actually rarely called in this case, because the off-chain validation that is done here is actually executed before. So in order for us to actually really check things, is to technically force the on-chain validation or amend the code and leverage this validation function in the off-chain validation. That is definitely possible, but not currently done in this moment in time. We'll skip over it as actually no, you know what, let's do it. We will not check the deadline. So what we're gonna be doing is just gonna go on chain. Possibly we will be spending some money more. That's at least what I expect. So we take this thing, we'll slap into the editor, we compile it. Hopefully everything is gonna compile and then we can make the test. This is really exciting. I've never done this before. Oh, completion is done. The example is still here. So let's make all the cases that we've done earlier on, we'll do them again. So we wait for slot 5, then we grab, this should actually work. Let's evaluate, we should see a transaction going out and a transaction going in from wallet 1 into wallet 2. And that didn't happen. Let's see if there is any error here. What was the error message? Wrong. Is there any wrong? Nope. Let's go back to the simulation 1 second. Oh yes, I forgot to put the extra weights. This should actually work. So we should see the money getting back into the second wallet. And yes, the money going to the second wallet. There are no exceptions, I guess, no errors. So yeah, that worked. So let's try to make now to increase to 15. We evaluate again. This one shouldn't work. Now let's see what happens, because technically the off-chain validation is not comprehensive. So there we go. We should still fall back on the on-chain validation. We can actually see the two errors. Exactly. In this case, either it was the wrong beneficiary, or if it was the correct beneficiary, the transaction, the deadline was expired. Of course, both things are failing here, because on one side the deadline is wrong, on the other one it's the wrong beneficiary. So we definitely know that both conditions are wrong. Fine, this actually worked as expected. So let's go now to test the other case. Instead of wallet 2 grabbing, it's going to be wallet 3 grabbing. Sorry, wallet 2, instead of being wallet 2 grabbing, it's going to be wallet 1 grabbing. Then we still have to add another weight. This should technically work. And this should technically work exactly. We can see wallet 1 getting the money back. If we shorten this to 5, this should give us again an error. And we should be able to see the on-chain error. Exactly. So if we look for this one, the on-chain error is here. So everything as expected. The last thing that we're going to be doing, and my guess is that we will not see anything, is that if we use a brand new wallet. The reason why I think we shouldn't be seeing anything here is because the off-chain validation is actually already excluding the wallet tray from it's validating already the wallet tray, and is there not going to be any UTXO with that exactly? We will not see any wrong either, because I'll show you now into the code. The filtering is basically the grab of the filtering is already checking if the public key hash is a legitimate one, and the beneficiary, this is like a beneficiary tree. The wallet is not part of the list, so it gets excluded. So if it gets excluded, the transaction is failed, and it will not even be executed on the chain. So this basically closes the first exercise. So let's move on to the next one. The next one is a little bit more complicated because now it basically breaks down, it introduces another parameter. So we will not have the validation function that is only made by the datum, the redeemer, and the script context into a boolean, but actually has a parameter called the pub key hash. Basically what happens here is that there is going to be a different script and script address and hashes and so on and so forth, differently from every single for every single instance of the contract per wallet. So in the previous case, we will have basically just one script for all the donators and for all the beneficiary and for all the people giving, for all the people receiving. In this case, there is going to be exactly one instance of the script per destination for receiver. But this complicates things because this function is not does not have 3 params anymore. It has actually 4, so this complicates a little bit how those things should be implemented. The first thing that we have to do though is to actually implement the code. So the logic behind the script is exactly the same. This is the best thing. There is someone who gives the money, someone who receives the money. There is still a validation slot that is basically the only type within the datum. So it's not a data type anymore. So let's put names in here. We put here, it's like the P as the public key hash. This one is going to be the slot. So the datum, the redeemer, we still don't care, and then we need the context. I'm still going to be calling it context. In this case, there is no need. Well, we still need to validate. So let's make trace if false. I'll just make a generic error, and then we have to do a check beneficiary. As usual, to where, so that we can define our function, and then check beneficiary is a boolean also in this case. Gonna be using the lazy approach, and because I'll definitely need this information as well, I'll just copy and paste from the previous exercise. Let's indent everything properly and now implement the check ben. Oh, I hate when this happens. So how again we implement check beneficiary? This one is again very similar to what we've done. Actually, you know what? I'm lazy and I'm going to be copying this one again. So I still need to check that the beneficiary is actually the one that is signing the transaction. So in this case, I don't need beneficiary dot, but it's just P is part of the signatories and from transaction info. And then I still need to check that the slot, that in this case is already available. Actually, I don't need deadline dot, but this is just like slot. Sorry, lowercase slot contains the range, and range is still defined as from transaction info and transaction info from the context. So yes, this should actually work already. So these two steps are exactly the same as before. The slot and the public key, we don't have to extract them from the data type anymore, but are already directly available. So I can use this one directly here, and I can use the slot directly here. This is again is going to create an interval, and then it's going to use contains to check if the type is if the range is within the valid interval. Now let's implement those those things. So I think the vesting data type should be fine because the datum is of type vesting and is the vesting is of type slot, and that's good. And I think that's fine. But now there we go. The inst needs to be fixed. So what I'm gonna do is I am going to be lazy. I know that this one is a script address that is a function already available, and I have to pass the validator. But there is something here that is missing. We have to use function composition because basically source address now is not a function anymore that returns a ledger address, but it is parameterized by the public hash key. So basically what we have to do is take this param and pass it to the validator. The way we can do this, we're actually going to do this in two different ways. We can use function composition, it is the dot, or can we actually do a script address of validator of, actually I have to change something here. I need to do something like, so this one is going to work like this, but if I want to do this the other way, I need a variable here and I need to pass the p to validator, but in order to pass this to validator, I either put these guys or I have to put the $sign. So at the moment, let's keep it like this. Now the pub key hash, I actually can't remember, excuse me, how to do this. We're going to be lazy. We're going to use this one. That's simple as a script validator script. That was easy. Should have remembered that. And also in this case, you see that I have to pass the dot because even in this case, pub key is parameterized. And now what I have to do is to take the vesting type, the inst that I'm going to be copying and pasting here as well. This is correct, this is all correct, this is all correct. I think that I have to change something here though, because the script validator is now as a slot here. And this is the datum and this is the redeemer. So this should be good to go. Let's see if the rebel agrees. And I think the rebel agrees. Oh, there we go. Little typo. Fantastic. So as you can see, this approach worked. Let's try to use the second approach. Fantastic. And let's use the third approach. It all compiled. So why all this compiled? I think this one is basically using the so-called function composition, or also there was someone else, point free. Point free is basically, if you want to know more about this, this is the way you can compose functions. It's actually really handy because it means that you can, if you have two functions of which the return type of the second one is actually the input type of the first one, what you can do is you can just concatenate them. And in Haskell this seems to be like really elegant. And you can see these. I'm gonna put the links to those pages where I found a solution to this problem. You can see how, for instance, in this case you have even and auto, where basically the first one from integer returns a bool, and this one from a bool returns a string. So basically you can concatenate even and auto. The way you can do that is just like using the dot to compose them, but then you need also like a big deal of parentheses. But this is just to explain how things work. In this case, in the source code, what actually happened, I think it is actually happening, this is saying, as you can see, source address is actually not defining a parameter here at all, but basically what is happening here with the dot is basically saying take whatever was passed and slap it into the validator. Or you can read this one as source address is now a function that gets a param, then calls validator p first, and then takes the result and put it into script address. But you can also rewrite this one with using the dollar, that is a type class. I think I was briefly touch basing this one, the dollar sign, in the past. This is again the dollar sign, and you can see that it basically changed the associativity and changed the precedence, so giving lower precedence. Instead of being associated on the left, it's going to be associating on the right. And what that means is usually that is used instead of parentheses to associate things that otherwise wouldn't. So I strongly recommend to read this page to know more. But as you can see, there are like 3 different ways you can come up with code that actually works. So just out of curiosity, I'm going to be using the 3rd version, the one with the dollar. I'm going to be slapping this into the source code, into the editor. I'm going to be compiling and see if this beauty works. Compilation is done. Let's go to the simulation. I'm actually surprised that the thing is still here. The slots are still there. This is weird. Did I copy the correct one? Yes. Let's give it a refresh. Are the inputs? Yeah, let's do the 7. Yeah, there we go. This looks better now. 1000, 1000. The first one gives, we need to get the hash again. That is this one. The slot is still going to be the 10th. I'm going to still be giving 150. 1 slot for the things to settle. Then we grab, because we are still within the dead slot. And then we wait for another one. And then we evaluate. And that actually didn't work. Why would that be? Did I add, as usual, the last one? Yes. This is wallet 1, we're in 1 block. Wallet 2 tries to grab. This is a little bit weird. Let's check the code. Made a gift of Loveless. Let's see if this thing is into the logs. No gifts available. This is strange. This is Genesis. Made a gift of 150. Wallet 2 tries to grab. I'm gonna second now. Let me just remember something. Oh, sorry, this is a little bit different. This is actually a different thing. This is, I actually think I implemented the wrong thing. Here we have to wait for the deadline to be expired. So this needs to be from slot. And then if this one is okay, so let's take this one, put it back into here. So basically here is the example that the professor is saying. If you want to make a gift for someone to just get this money on their 18th birthday, for instance, so you will be allowed to take this gift only after a certain threshold. So the deadline actually needs to be expired. So let's do again the example in which the wallet tool is not allowed to grab. So you should still only see the genesis and the first transaction. That's correct. So if we now wait the 15 slot and we execute this one thing, now wallet tool will be allowed to take the money, basically. There you go. Sorry, it was all the way around. With the difference here is that if we go back to the example, I think this works better if we use two wallets. So instead of having wallet 1, we do also wallet 3. Sorry, we'll take this one in the meantime. So we get a wallet 3 as well, and then we say that after all this, actually we delete all this and we say that wallet 1 gives and wallet 2 gives. This time to wallet 3 is gonna be after 15 and it's gonna give 50. So we have that wallet 1 gives to wallet 2 gives to wallet 3. Then we wait one block for everything to happen. Then, sorry, we have to do at least, let's say in this case, we just make both things to work. We wait 20 slots and then we grab wallet 2 grabs, wallet 3 grabs, and then we wait for one last block. So now we should see, first of all, two different scripts. Two different scripts because we are using the pub key hash of the two wallets as a parameter of the script, and this is going to basically generate a different bytecode. So this is the first script that begins with B48 and this is BD7. That's it, two different things. Then the number of required slots are passed. So B48 wallet 3 gets, BD7 wallet 2 gets, and now all the monies have gone around, and this is exactly what we wanted. So with this thing, the second week is over as well. So happy days. Looking forward to week number 3. In the meantime, I'm gonna be showing you like a subscribe button and a link to other videos. Thank you very much for following me if you got so far. I hope this is interesting content for you. My name is Giovanni, also known as CryptoJoe11. I am a stake pool operator. I have my own Cardano stake pool. If you like the content, smash the subscribe button, hit like, and if you want to support me, consider delegating to my stake pool that is called Easy One. Thank you very much, and I'll see you at the next episode. Bye!